Well, good morning, everybody. I know it's always hard. The first session in the morning is always the hardest to get people out. I don't know whether it was too much partying last night or whatever, but anyways, good morning, and thanks for those who could come to see us this morning, because it's going to be very exciting discussions here. So the world of 5G, full speed ahead on next-gen networks. So I'm John Fielding from Ontario Centres of Excellence, and I'm really pleased to host this event today. And so it's going to be a really exciting session. For 5G, myself, I'm kind of going, didn't we just have LTE? Didn't we just go through 3G or 4G, or was it 2G and CDM? Anyway, so I'm kind of glad that we're going to get a little bit of insight into this. So I'm really looking forward to it. I'd like to remind you that if you're tweeting the session, it's hashtag OCE Discovery. So it is my distinct honor to introduce our moderator for this session, Michael Hainsworth, a senior anchor at Business News Network. Michael has appeared on local CTV newscasts across the country and hosts a number of BBN's top-rated programs. He made the transition into television after 11 years in radio, where he was a news anchor and business reporter for stations including 680 News in Toronto. Please welcome Michael.
Thank you very much, John. Good morning, ladies and gentlemen. We really appreciate you joining us here. This panel that we've assembled for you today brings together a collection of some of the major players in telecommunications today. We are going to be discussing the current global task of mapping out the next generation of wireless networking. Before we begin, I want to take the opportunity to introduce you to our panelists. Their full biographies, by the way, are available on the Discovery website. Our first panelist, Denis Flouet, is the Senior Director of Strategic Markets and Product Management at Ciena. He has more than 25 years under his belt in the telecommunications world. He's held a large number of management roles at Ciena and Nortel Networks. Currently, he's responsible for leading Ciena's emerging market segment strategy, and that includes digital economy, portfolio, evolution considerations, and things of that nature. Our second panelist is Greg Friesen. He's the Vice President of Product Management at DragonWave. Greg has 19 years experience in senior roles working on network design, planning, engineering for a number of communications firms. It's sort of a Nortel Networks old boys reunion here today. Innovance Networks, Fundy Telecom as well. Greg was also the recipient of the 2011 Ottawa Business Journal Top 40 Under 40. So those of us who are over 40 are none too happy to hear that. Our third panelist, Ivo Malijovic, is a technology strategist at TELUS. He's also an adjunct professor at the University of Toronto's Faculty of Applied Science and Engineering. Prior to TELUS, he has served roles with Soma Networks, Motorola Canada. Ivo's experience includes your LTE, your WiMAX, your CDMA. We'll get his opinion on all that ASAP. We'll talk about software-defined radio signal processing and digital communications theory, or not. But he certainly knows what he's talking about on that front. And our fourth and final panelist here is Dragan Neranic, the Chief Technology Officer for Ericsson here in Canada. Dragan has over 20 years experience in the telecommunications industry. He's actively participated in the standardization and industry organizations including 3GPP2, TIA, CDG. I know not of what any of that means. I don't know if we need to get into that today. I hope we don't need to get into that today. But I'm very pleased to have this very impressive panel here for you today. We will have a question and answer session as well, and we've got the microphone set up, so if you could hold your questions until later on in the session. We've got 7 or 8 key topics we want to be talking about here today. What 5G means to the average person, what the role of the Internet of Things is in adoption rates for 5G, really what can you do with the technology generally speaking, and then that sort of chicken and egg issue as well. Do you develop the technology first and then let the developers come, or do the developers need to be there to help propel the technology? We'll talk about the interoperability standards, things of that nature, and some of the key hurdles in adoption. We'll talk about the fact that it's right around the corner. 2020 is the expected adoption rate for the technology to be deployed. And then we'll find out if the panel thinks that the government needs to be opening its wallet to help fuel the growth and development here in Canada. First, we want to talk about what 5G means to the average person. And Dragan, this has got the potential to exceed fiber to the home. We're talking, what, 20 gigabits a second in 5G?
Correct. 5G is promising, and not only promising, but already started delivering in early trials fantastic data speeds. And we demonstrated recently, and announced this year, that with Entity Docomo in Japan, we demonstrated over 20 gigabits per second over-the-air speed. But 5G actually solves even bigger problems than that. For an average person, if you really take a look how our homes look like, we have fixed broadband connection, but we really don't want to be fixed. We want to be wireless in home. So we use our smartphones, which have already 4G, but 4G is kind of a little bit expensive, so we want to go on Wi-Fi. And then we have from fixed technology to wireless technology, but not mobile technology. And then we have lots of sensors at home and locks and cameras, and we use Zigbee technologies because all other technologies have their deficiencies. And then we want to have some communication, we use Bluetooth. So the problem is we have too many technologies, and for us who are technically inclined, that's maybe fun, but not necessarily for each and every person. So the way how we see 5G is the technology that will overcome limitations of multitude of technology and being able to establish one technology for various types of applications and uses, therefore simplifying life of average person and creating really big ecosystem of various devices and various use cases that can be applied.
So Denis, is this the kind of thing where the quality of experience improves beyond just speeds? It becomes ubiquitous. We don't have to think about it as the end user.
Exactly. So when you look at 5G, as Dragan said, you need to look at it from a broader picture. It's not only the wireless, it's also the wireline piece of it. All those technologies needs to align to deliver the right quality of experience to the customer. So it's an all-inclusive experience that you are delivering, whether you're on wireline, wireless, or this type of devices. So it's related to each other. And why is this relevant if you guys are entrepreneurs? Think about, if you look at the 3G, 4G business, Apple has brought us innovation leveraging wireless. Netflix has brought innovation leveraging internet. Amazon Web Services has brought innovation leveraging compute technology. So look at the telecom network and look at what 5G can do as really a platform that can foster innovation and can create the next Facebook, the next Google, the next whatever else is out there. Is really the way that you need to look at it from a consumer perspective, but also as an entrepreneur, look at your business and how you can leverage this as a way to foster your innovation and your business as well. So it's quite a broad spectrum of innovation you can bring to the table here.
Yeah, and I think, from a customer, I think what you have to expect is that's going to be the main benefit, is that convergence of technologies, the enablement of many more devices, so the Internet of Things, being able to have low power devices that can last for a long time, sensors, it can just do quick data connects, things like connected cars. That's where the value is going to be. If you're expecting that you're going to get fiber to your phone everywhere, that's probably not really what you're, yes, we will have trials of that for sure, but that's a spectrum dependent thing. So if the government decides not to allow spectrum for that, there isn't in 5G, we haven't broken physics. We're not all of a sudden introducing a new technology that in the same spectrum can do 10 times the capacity. Basically, whatever increase in capacity is going to come only through an increase in spectrum. And many governments aren't going to give an increase in spectrum. If you look at the US auctions, their current 5G auctions are about 180 megahertz of 600 megahertz spectrum. So it's similar to the amount of spectrum that's there today. Unless you go up into the higher bands, the 70, 80 gigahertz bands, 60 gigahertz, maybe 38, some people may do higher bands that do wider pieces of spectrum that allow high capacities, but that's not going to be global. And even when it is done, that's going to require a much more intensive amount of equipment from the mobile operators and a much more expensive network. And it's not yet evidence that the business case for that works. So the expectation that in 2020 you're going to turn on your phone and you can cut your LAN connection, is not something that I believe is a reality. That may happen in a couple places, may happen in Korea, may happen in a few places. Globally, I think that that's a big, big stretch.
Ivo, when it comes to TELUS, when we talk about what 5G means for the customer, I think we probably need to define who the customer is, because it's not just the Joe average with an iPhone in their pocket. You're talking about the corporate world as well.
Exactly. So if we take a historic perspective, in the early 80s, the first generation of mobile phones was intended for one purpose only, and that was for voice communication. And then as we progressed over the years and then we introduced new generations of mobile communications, every new generation added a little bit by adding limited data services, and then third generation added more data services, fourth generation simplified the architecture, added much higher data rates in hundreds of megabits per second, and added the corporate and enterprise markets. When we go into the 5G, there are three major components of the network that are aiming to target. One is still the enhanced mobile broadband, which is the customers with cell phones, but with much higher data rates. The other is ultra-reliable, low-latency communication, which is intended for medical applications, for robotics, for tactile internet. So for anything that requires very low latency and very high reliability. And the third market segment is the Internet of Things. So we already have most of these components are evolving, and we have the solutions. But the 5G is going to bring them all together under a single umbrella instead of having diverse solutions, as Dragan alluded to earlier. To have such a diversity of technologies under single umbrella and to have such a vast amount of capabilities will require much lower energy, much better energy efficiency, much lower power consumption. And this is where we see 5G as a critical component for us, because we will need to deliver much better performance, many more services, but the customers will expect a similar level of cost to them.
You mentioned the low latency. We go from 10 milliseconds down to a single milliseconds. And for your customers, not the Joe Schmo with a smartphone in their pocket, but for the corporate world, we know that, for example, in the oil sands, they can build these networks that they put up and they tear down so that they can remotely control these massive vehicles. Exactly. And at the end of the day, when they're finished with that particular pit, they have to take it all down and move it somewhere else. I can imagine 5G eliminates the need to be building your own private internal low latency networks. You can just take advantage of this next generation.
Exactly. This is where the economy of scale comes into play, because there will be a global solution for all of these problems. Now, I would like to take this opportunity to educate the audience a little bit. The numbers that you see, 1 millisecond, 10 milliseconds, they are correct. There is nothing false in these statements. But the reality is that 10 milliseconds in 4G is something that happens from the UE to the first gateway, to the first network node.
Not for the end user. Not
for the end user. So the end-to-end latency is between 25 and 70 milliseconds. And the same thing will happen in 5G. The 1 millisecond will be for a very limited segment of the network, but the end-to-end latency, the target is really 5 milliseconds or so.
Yes, to add what Ivo said, 5G actually will be a very different technology relative to all 4G previous generations of technology. Because in all previous generations, all devices had to behave the same way and respect the same protocols. With 5G, we have completely different approach. And that approach actually separates different types of devices that have extremely high capabilities with extremely high data rates. And on the other side, we have devices that really need extremely low cost, extremely high battery life, like for sensors that can be actually be disposable. And with 5G, we have ability to have completely different protocols for these different types of devices. And therefore, we can achieve extremely long battery life for those devices because they will actually have different protocol and they will have a very low cost. On the other side, we will have very high performance for devices that will be suited for that. And those devices actually that have a very high bandwidth, very high performance, they will have their own segment, and some of them will be used for fixed access, as Denis indicated. So we're going to have different types of devices at different cost points and different performance points that will work in the same network. And the way how we actually manage to do that, we introduce concept of network slices, where each one of these devices believes it's the network just built, optimized for that type device, and it will efficiently work that way. What it does, to give you perspective, and you mentioned about the automation, we are introducing tactile internet, which means that we can take advantage of these capabilities and introduce remote operation of machinery. We demonstrated at Mobile World Congress ability to operate machinery that was located in Sweden from Barcelona. And we realized that there are so many people that work on construction sites, on high cranes. Why do they have to be there? Because they have good line of sight to the hook that is about 60 meters away. Actually, camera can be installed anywhere, could have much better visibility. And that person in that confined space that's always shaking, hot in summer and cold in winter, we can put that person down to the ground. Or maybe we can put him in a nice office. And when the weather is bad at that site, he can work on another site. And we completely change the way how other industries work and operate. And we see that other verticals will take advantage and completely transform their own industries. And that is why 5G creates enormous potential. That conceptually it was possible with previous generation, but they were not good enough, not efficient, and not practical. With 5G, that changes everything.
So that's fascinating that in the 4G world and prior to that, we were focused on pretty much one idea of pumping as much data as we could, but we don't necessarily need to have high bandwidth, high volume data traffic when you're dealing with smart home sensors that only need to ping a server maybe 6 times over the course of a day. So that gets us that 10-year battery life that you're talking about. Ivo, we were discussing other technologies tied into this as well. The fact that the 5G technology has the ability to transmit and receive when it's moving at 500 kilometers an hour suggests this would be perfect for the autonomous vehicle industry, vehicle-to-vehicle communication.
Yes, exactly. So back to that 3 major market segments, and within them there will be many different verticals, many different markets, but exactly. So there will be enhanced mobile broadband with speeds up to 20 gigabits per second. But then there will be ultra-reliable communications where you will have 5 nines, and you will have the capability to have one of the key targets is exactly to support about 500 kilometers per hour.
Tell me about the vehicle platooning, though. That was absolutely fascinating.
That is an example actually we did with a Swedish transportation industry, and they actually realized that it would be possible to achieve huge savings in truck industry, in transportation, if trucks could actually drive very close to each other, like a train.
That jackass in the BMW calls it hypermiling.
Well, the problem is that you have actually to control braking, because when the first truck brakes, immediately all trucks have to brake, and humans absolutely cannot drive that way. That's the reason why we have big distances between vehicles when they drive at high speeds. With extremely low latency, we would be able to drive them very closely, take advantage of aerodynamics, and they're saying they would save 15% on transportation cost, on fuel. That is enormous saving, enormous reduction in greenhouse gases, enormous benefit to the entire society, less vehicles. Actually, we can put more vehicles on the road at higher speeds. So there are lots of impacts that actually are coming from great technology advancements that Ivo mentioned. Low latency, what does it mean? It means so many things that now can be implemented.
Just to add and to put things into perspective, though I believe that the audience is quite technically savvy, a human brain reacts within 30 milliseconds or more. So we are talking about something that is faster than a human brain reaction 30 times. But it is a necessary component well, if you want to trust those cars, if you want to be driven by these cars, you really need to have an extra degree of margin compared to human drivers.
So the role of the Internet things in the adoption of this technology has a large corporate promise. But from the consumer side of things as well, I just got another ping on my phone reminding me to replace the batteries in one of my humidity sensors in the bathroom that will automatically turn on my fan if it gets too humid in the bathroom while you're having a shower. It didn't happen this morning because I didn't replace the battery. But there is a consumer component, Denis, I'm sure, to this that will help drive the adoption rates as well.
Oh, for sure. When you look at it from, you need to look at this from today. In today's world, we're basically consuming in one way, I would call it. You get access to content. If you look at what we're going with 5G, with all the applications that this technology will enable, you need to look at it from a multi-technologies, multi-experience, and collaborative domain perspective. So yes, the sensor is coming in, there's other action coming in. How do we correlate all this information and take actions accordingly? So it's not about just consuming a video, consuming a one way. It's about different inputs into the process that you make a decision on it and you act on it. And that drives some of the sensors. You may wait for 24 hours to make an action, that's fine. But as Dragon and Evo were discussing, there's some actions that you need to make a decision right away. A fire alarm is going in, there's something wrong, you need to take action right away. So it does have impact on the day-to-day business as well as the business-to-business and the broader applications that we will discover over the next few years, actually.
Greg, as a tech guy, you can give us some insight into the fact that 4G, you had to be connected. 5G, it's a connectionless connection.
Yeah.
What does that mean?
Well, it's expanding on what Denis said. You know, one of the enablements of the low battery power is right now when you have a device connected like your sensor, it's establishing a connection and it's sending and receiving data. What we'll be moving to is you just, when you want to send something, you send it. So, okay, I'm alive and the temperature in here is 20 degrees. I just sent, 20 bytes. That's all I had to send, and I'm not going to send you anything again until I'm ready. There's a change in temperature by 2 degrees or something like that. Rather than establishing a connection, sending a lot of data, using a lot of power and a lot of your battery life, you can now just do very quick data bursts only when they're needed, using a very small amount of power. And that will enable lower power usage, lower cost sensors, and sensors that can be put in places we haven't even imagined yet. So they're going to start to, from that, there's going to be sensors and applications for sensors that we haven't even begun to think of.
Well, to that point, do we need to, is it a case of build the technology and they will come? How do we get the developer community taking advantage of that massive leap in capability that 5G offers? Do you just have to build it and wait for them to realize it?
Yeah, well, it's, one of the things I think with 5G, the standards body has taken more time looking at these applications up front. 4G was a lot more of, okay, we'll go to the next modulation, we'll do wider channel sizes. 5G has looked at this and they're, what do we need that 4G is not offering? We need more higher speeds, we need longer battery life, we need more devices. And so it's come from that angle. Now there's going to be a bit, once this standard's established, there is going to be a bit of a wait period that, it's not like these devices are going to be available tomorrow. Certainly the standard has to get established, the infrastructure has to get rolled out. That will take many years, and then you'll start to see the applications are going to develop and the sensors are going to develop on the consumer side. But I think it will be natural. People, entrepreneurs like here at this show, they'll see the opportunities and they'll start to explore them and they'll take advantage of the infrastructure that will be put in place.
To developers, actually, it does solve very practical problems. Today, you have to go through fairly cumbersome process of activating devices using various hubs, routers that you have at home. The process is manual. It requires manual configuration. It requires existence of some additional components that you have to have in home in order to connect. With 5G, it will be a global standard. It will have basically ubiquitous coverage. You know that if you ship in certain country, it will work everywhere. It will work automatically. It can be configured without human intervention. It will address communication needs that are appropriate for that device. You don't need any hubs. It will establish predominant design of connectivity, and it will establish a very large economy of scale and global mass market. And from that perspective, you know that you're not developing for that particular proprietary technology. What you are developing is something that can be marketed across the globe. And that is a huge potential, and that is actually what attracts and motivates developers to embrace the technology.
Yeah, I'll just add the operator's point of view angle to this whole story. So there is a component definitely of 5G where you build it and wait for them to come, and it will foster innovation, but it will solve several problems that operators are facing. Again, I'd like to go back to the historic perspective. The first generation mobile networks had maybe 5 parameters to tweak. As we went from the first to second generation, the number of parameters increased 100-fold. And then with third and fourth generation, it further increased. So the number of parameters that you have to optimize has become huge. So it creates a tremendous operating expense to operate the network. Some of the solutions, such as self-organizing networks, are starting to show up within the 4G. But the expectation is, and it is our hope, that 5G will have it properly incorporated from day one, so that the OpEx is really kept low, and the number of parameters that have to be optimized is unmanageable by human being anyway. The other problem is the rate of service introduction. You need to introduce Internet of Things, machine connectivity. You have to go and see which of the technologies you want to select, because there is a multitude of them today. Then you have to see how do you integrate whatever you choose. It takes time to do the IoT testing. With the 5G, that will envelop not just the new radio interface, but it will have a completely redesigned architecture that will be centered about network function virtualization. The time to introduce a new service will be brought down from a year down to minutes or days.
So if somebody comes up with an idea, it can be implemented very, very quickly.
But you just decide through the software-defined network, you decide which of the network nodes which are defined in software have to be interconnected to the Dragon's point, the network slices. You define them on the fly and you interconnect them. So it does solve several immediate problems, at least for the operators.
And I can imagine as an operator, the ability to scale the technology is massive as well.
Yes.
I was fascinated to learn that in a space of about the size of this large room, you could have something in the neighborhood of 200,000 devices connected in a single square kilometer.
Yes. Well, yeah, exactly. So that's the connection density that you have to support, but you have to scale your network as well. And building base stations the traditional way is something that cannot be sustained. So the 5G will answer that challenge as well.
So it sounds like when it comes to the chicken and egg issue, you are going to have to build out this technology, make it available, and Greg, we should probably get into the whole issue of we haven't really nailed down any of these standards yet anyway, because there's such a varied world in which we live. Some governments may be inclined to adopt certain spectrum, others not. But you've got to get those chips into the equipment before anybody's really going to take advantage of them. What are we looking at here as far as that regulatory world at this point?
Yeah, so certainly the regulatory will be a major hurdle. It's going to be an issue globally. When we talk about a global standard, that's going to be one of the obstacles is, will there be global spectrum? Will it be ubiquitous spectrum? Already the US is talking about using very low spectrum. Other operators in the US have, for example, Verizon's purchased some 28 and 38 gigahertz spectrum. In other parts of the world, they're looking for very high spectrum. So one, can you get a device that can manage and work across all of those spectrums? And two, depending on what spectrum you have and what spectrum the country adopts is going to change what the architecture and what capacities you're going to be able to see. In the US, at the low spectrums, you're not going to be able to see tens of gigabits. If you go and adopt 70, 80 gigahertz or 60, 38 gigahertz and do a very wide swath of spectrum, you may be able to get higher capacities, but it may result in a more expensive network architecture. So there certainly is going to be a challenge for can we do a global standard when regulators aren't necessarily willing to do a global set of spectrum? And then how do we manage that from a device and really get the economies of scale, because we do have this global standard, but the regulators haven't agreed on having global spectrum. And so how do you then really have a device that is ubiquitous and global, or do you end up having multiple devices that work in different parts of the world, or do you have a more expensive device that has 5 different RF devices in it to be able to work in all parts of the world? That's one of the areas that's going to have to get tackled. The other is, and we talk about this standard, at the same time we talk about Korea, for example, and Korea is deploying before the standards even planned to be in its first draft. They'll
2017.
deploy. Yeah, exactly, and the standard's in 2018. So certainly there won't be a ubiquitous global standard because Korea is going to be deployed before that. Japan will also be probably deployed for that, and Verizon has said they'll be deploying before that. So there is going to be different versions of the standard, pre-standard, standard, and probably a couple versions of different frequencies in this standard. So there is certainly going to be obstacles around having global interop. Because of that, and some people aren't willing to wait, and there are frequencies and regulatory obstacles that they have to get around.
Great, so now I'm firmware updating everything, including my TV, my sensors at home. Denny, from Ciena's perspective, do you just basically build out a mega radio chip and just have the ability to incorporate all of the spectrum, or do you have to go small, low cost, and as Greg points out, a patchwork?
Yeah, Ciena is in the what we call the transport business. So basically connecting towers to where the data is getting processed between cities, between all those locations. So we're really at the transport layer. For us, a bit looks like another bit. So there's nothing specific about it. What will be specific is how at the edge the data will be mapped, which protocol is going to be used, and hopefully it's going to be a standardized packet network. So from a transport layer, what Greg is going through is really the front end to what is facing the external world. When this hits the network, basically gets on the wire, and for us, we just need to understand the scalability, the latency requirements, as we discussed before, and the connectivity patterns that come with it. But we are a bit decoupled from which frequency and why and how and which country. So we're a bit an outsider to this frequency discussion at this point. But I think, Dragan, you had a point on maybe spectrum.
Yeah.
Well, what I wanted to say, we are in early days of technology or generational transformation, and we've seen these things happening with previous 4 generations. There are trials before the technology is fully standardized, and it's necessary to understand how it will work. It's necessary to understand how to design technology, and even before we actually finalize standards, we need some feedback from simulations and field tests to make sure that we have the right standard. Because once it's developed, when it's finalized, then that's it, and we have to live with that. And we realized that some generations of technologies, they did have their limitations, and we had to address them later on in further releases. So I'm not at all alarmed that there are going to be trials. And it is, in fact, very encouraging that trials are taking place. And with 5G, again, it will be different, because 5G may even start with applications for fixed broadband to probably complement, not to say replace necessarily, fiber to the home solutions. And Verizon made a very interesting announcement saying in 2017 they would like to explore if they can complement that with fiber to the home. So that means that if devices are fixed, they're not going to roam around the world. They don't necessarily need a very small form factor, and they're not really limited with battery life. So if they go with something like that, it can actually bring these devices faster to the market. And in the meantime, industry will spend time now to make these devices smaller, cheaper, globally acceptable and interoperable, and that will create dynamics and adoption of technology. So I think that 5G actually is moving very fast, and level of adoption by operators and level of interest and trials. At Ericsson, we announced over 20 trials with operators worldwide. and to the point that we haven't standardized technology, and operators are eager to start seeing benefits of the technology. So certainly shows lots of encouragement. People are in agreement that approach that is being taken for 5G is the right one. It addresses real limitations and real opportunities for both telecom and adjacent industries, and that's why there is so much excitement around it.
Ivo is the man behind TELUS. Where is TELUS on the adoption of 5G?
Oh, we are actively involved in through the standardization bodies such as 3GPP. We actively participated in the development of NGMN 5G white paper. We are sponsoring about 15, 20 universities in Canada doing the 5G research. And we are evolving our network. We are building the infrastructure that is going in the right direction. We are building a lot of
You're not going to
fiber.
have to tear down the 4G LTE network, though.
No,
You have to build on top of that?
No. Let me tell you something that interesting about the mobile generations. You know that from the moment the new generation is introduced until you reach the peak of the technology, it takes about 20 years. So the 4G was introduced in 2010, and it will reach the peak in 2030 on a global scale at least. So we are not going to tear down 4G. Even 3G will.
So
go,
don't throw
will
out
go.
your pager yet.
Yeah, no. But so we are preparing ourselves, and we are building a network function virtualization approach that will bring us closer to 5G. But it's not only, even if the 5G architecture is slightly different, we are building the core set of skills that will help us better transition to 5G. But I wanted to touch upon one thing that you started going in the direction, what is the role of government related to the spectrum? And then we diverged to something else. So the spectrum nowadays is quite a mess, if I can use the simple term. The current mobile phones have to support over 20 bands if they are to operate on a global scale. However, the 5G will incorporate bands above 6 gigahertz. And the ITU has a role in defining the mobile bands. So in 2019, there will be a World Radio Communications Conference, or WRC 2019, when they will declare bands above 6 gigahertz, between 6 and 100, as mobile bands. And this will be the point where the governments can finally start to work together and to align these bands properly so that we don't have problems like we have nowadays, that we have different bands across every country.
I can imagine that governments also have the incentive to standardize a lot of that spectrum because there's money in it. They will be licensing that to players such as yourself.
Of course, because if you have an economy of scale, as an operator, you want to buy a spectrum that works well for you, that supports the global device ecosystem. And the government has the incentive to align the spectrum so that they can make it more marketable.
They certainly do, but not necessarily globally. For example, 38 gigahertz isn't used in the US, so that's a great spectrum for them to go and do that. It's used heavily in Europe, and they're making millions of dollars in every country, so they don't have the same incentive. So doing that globally is this real challenge. You're right, each country has for example, what Canada wants for spectrum, because our spectrum policies, I sell in 50 different countries, it's very different, the most different than almost any countries, especially in those bands, is entirely different than what the other countries want. So getting them all to agree is going to make some of the recent climate change pacts we've had look simple. This is a very, very difficult thing. So, and it's going to end up, in reality, there are still going to be many frequency options. If we want to fool ourselves that we're going to walk out of there with a single frequency and we're all going to deploy on it, it's very unlikely that every government's going to agree to that. We may be able to get some big caps that we can get, one cap of 50 countries agrees on this, another 100 countries agrees on that. It'll be very difficult to get a ubiquitous spectrum.
We're going to go to the audience now for questions. If you have a question, we do have 2 microphones set up here, and we'll just sort of ping pong back and forth between them. If you can't get to a microphone, just put your hand up and we'll run one out to you now. So we'll get about 15 minutes or so if you've got any questions. Crickets. All right, I have one last question. And maybe each of the panelists can offer their opinion on this, and we'll just start, Denis, with you. With South Korea investing, what, $1.7 billion into 5th generation, just as a state itself, does Canada have an obligation? Should we be opening our coffers, and should taxpayer cash be going towards helping drive adoption and putting us front and center?
I believe so. If you look at what 5G can bring in terms of an economic growth vectors, and don't look at it only with what the 5 of us can do in terms of technology, but look at it from how this technology can create innovation at the entrepreneur level, at the small, medium business, at the startups level, academia. You look at the full ecosystem, there's tremendous value for Canada to jump in the bandwagon and make this an economic priority as a growth vectors going forward. It's clear that that's how you foster innovation. That's how you look at it from look around in this conference room. Basically, you can get partners to collaborate with each other. If you have listened carefully to what we said, it's basically, there's no one simple answer. If you look at different verticals, being healthcare, transportation, it's going to be a sum of many things. So collaboration will be front center of it, and I think we can foster this collaborative model in Canada, and it's not too late. 2020 is the date. We still have time to get our act there and to act on it in Canada.
All right, I got 3 nods to what you were saying there, so if we'll maybe put the other opinions on pause for a moment because we do have a question. Hello, sir.
Hi, thanks for the great talk. You've addressed how 5G will influence speed and latency and battery life, but I'm interested to see what your opinion is regarding sort of bandwidth usage. So in the last 10 years, we've seen 10, 100 times speed increase, but really the amount of usage you can use on a cellular network, for example, has barely, or if not at all, increased. So what can you tell us about 5G that will help alleviate the bandwidth problem, using bandwidth in terms of how the cellular networks define it, not real bandwidth, but go ahead.
Try to address it. So that is an excellent point, and really, if you have a 300 megabits per second, you burn your 500 megabytes cap in 8 seconds or so. So we are hoping that with 5G, with all these capabilities, that this will be the first time where we be able to compete completely with the wireline telecommunications, and the data caps will be either quite generous or they will go away. One of the problems with the existing technologies is that you do have these high data rates, and in the burst you do see a high speed. But if you try to allow every user to have a high cap with the existing technology, because they all share the same communication channel, all of a sudden their speeds will drop down to a crawl. With 5G, it's not just the high data rates, because even 20 gigabits will not be the answer, but the densification of the network, the so-called ultra-dense network, will finally divide and conquer that space where you will have 1 or 2 users per base station. And that will be finally the point where you will no longer have the pain of 1 gigabit cap or 2 gigabyte data caps per month.
Just to follow up on that, so the densification you're saying is going to drive that?
Yes.
So does that drive up the network cost by the same factor then?
Not necessarily. That is one of the things that I tried to mention earlier, is that the efficiency of the network and the cost per bit has to go down significantly.
Right.
But it is a business model. Certainly 5G doesn't enable densification. It is enabled in 4G. In fact, there are 3G small cell networks out there. So it does come back a lot to a business case and how dense the operator is going to be able to justify that. One of the things that is going to happen, is already happening in 4G, is there are lower cost small cell base stations that are coming out that will continue to evolve in 5G. It is going to be a much more distributed architecture that will allow for that. And there are smaller devices that can be deployed more easily and lower cost at more locations. So certainly the economies will start to look better, already are looking better in 4G, and will get even better in 5G for that. But it's less a technology capability and more a business case argument.
Okay, and is there any more enabling technologies in 5G, such as cognitive radio, meaning like breaking down those walls between defined spectrums and then utilizing the white space in an area that's not being used? So if you're familiar with cognitive radio or not.
Okay, because
Go
of
ahead.
the signal processing background, I guess I can answer, and you can also
go ahead.
supplement. There are elements of that already in place, especially, for example, at 600 megahertz today, there are TV white spaces, and there is a level of cognition there. The radio is capable of scanning the channels, but they also talk to the centralized database where they see which channels are available. This will go further in 5G. There are certain portions of the spectrum, especially in the US, around 3.5 gigahertz, where sharing will have to happen. So a high level of cognition will happen in 5G. It's already underway. I keep repeating this theme. There are all of the things that will be in 5G exist today. They're just not packaged nicely. Like the OFDM that we use in 4G, that was known since 1960s. There is nothing new. And there is no new technology that will be in 5G that we don't know today. It's just how they will be packaged. But the cognitive radio, it will take some time to progress further, because making tunable radio is still not a feasible technology. Oh.
Okay,
Thanks.
thank you. You had a question, ma'am?
Hi, thank you very much. It was a really nice talk and informative too. I have a question that there are very good things and fancy things about 5G networks and 5G technology. So what you are thinking about the security or the access or the provisions, and because it depends, so many of the technologies are integrated and so many vendors, players, providers, the policymakers, so many organizations, they're coming into play together. So how you take care of that? Because you don't want that your kid driving a driverless car and somebody take hold of it, or you are in a shower and somebody is looking through your camera or the sensor. So how you take care of that?
Is 5G inherently a secure protocol, or is that based upon the development?
5G is bringing a couple of new concepts in the way how networks are built, and Ivo made comments about virtualization of the network functions. It will be based on cloud technologies, and provisioning and activations of services will be based on cloud technologies. Security absolutely is a very important issue from multiple levels of security and multiple aspects of security. And it is not only over-the-air security. We had encryption of LTEs fully encrypted from end to end, but it is more about access to data, access to systems and processes. So it is being looked at very high level, and architecture of cloud-based solutions will address that as well, because certainly we are talking about large number of systems that will be interconnected, and you have to make sure that overall system with interfaces with other adjacent supporting systems are properly enforced and secure. So that absolutely is one of the key concerns that everyone has.
But it's not like some particular measure being taken, or it's just like you're thinking about seeing the integration of policies. Like when you're talking about the cloud, you have so many of data from so many places and so many devices and so many people. So how it works, it's just I believe that it's not the technology hurdle, it's like more of the policy making and management of actual
Yes.
resources.
So just maybe to get, when it comes to security, you have to basically address people, you have to address processes, systems, tools, technologies, policies that are in compliance, and then solutions. So as you can see, there are multitude of layers that have to be addressed. So organizationally, you have to have proper authority for proper people, proper groups, proper functions. You have to have processes, regulations. You have to have proper standards of conduct. Then you have to have proper tools. You have to proper architecture and systems that actually do that. So Ericsson did acquire company specifically focused on security for the cloud, because we know that cloud security will be a big thing. So we made investment in that space, and we have partnerships and cooperations in that area as well. That is very important one, but actually, as I mentioned, include multitude of layers, because each one of them on its own is insufficient to address security concerns.
Just one more comment then. Do you think it's the more way to go, lot to go for the policy making, or a lot to go for the technological investment? So what is the...
When it comes to cybersecurity, I think that it would be great to increase level of awareness across the board. So it is from the policy to overall awareness in industry, because that area is moving so fast that many aspects of our society have to catch up with that. And we have to be one step ahead of those who have malicious intentions.
Denis, did you have something to add?
No, I was just acknowledging the challenge that we're going to be facing on security. And when you look at it from zillions of connected devices, that all of them suddenly create a session on the network, you can imagine the scale of security we have to deal with. So we're just supporting the acknowledging that Dragon's point are right. It's something that is front center of not only the 5G, but Internet of Things and the full experience that you get out of this. But it's not a small problem to fix, actually.
I can imagine as well, unlike a 4G LTE connection where you connect once, you establish the credentials that's maintained, in a connectionless environment where you're only attaching to the network on an as-needed basis. While that may not create a tremendous amount of overhead if it's a smoke detector type sensor, when you've got massive collections of IoT sensors all simultaneously pinging the network, they're all going to need to reestablish their credentials. Does that create a bandwidth overhead in any way?
It will definitely create a pressure point on the control plane there, right? And that's why when you look at 5G, it's clear that the architecture will see the user plane and the control plane will be decoupled from each other. Because if you look at the massive scale of this, there's no way you can let the current construct, which is a sum of the user plane, the control plane, all packaged as a single entity. Going forward, we need to decouple it because of the point you just made, Michael, in terms of my device, although it's not active right now, needs to be aware, the wireless network needs to be aware that my cell phone is here, I'm in idle, I may detect something and send it in 5 minutes from now, so I need to reinitiate a session, call the control plane, reestablish my credentials, the security, the policies, and everything else. So it's going to be quite intense on the control plane side when you look at the scale of those networks and how many of those connections needs to be managed on a real-time basis.
Well, thank you very much for your questions. We'd like to invite John Fielding back to the stage to conclude today's session.
So I want to thank you on 3 fronts, right? So the first is thank you so much for being here. I know some of you flew in from Ottawa and Montreal just for this panel and are zipping out right after, so I very much appreciate that. The second front is I want to thank you for not glazing me over. I tend to sit in some of these sessions, and after a few minutes in, I'm going, what are they talking about, right? So I really appreciate it that you guys kept it at that level, right? And the third thing is that after this session, and I'm a techie guy, so after this session, I kind of really appreciate that this is not about technology innovation. I mean, there is technology innovation there, but this is really on market innovation, and it's going to be a very transformative market innovation for kind of like the first time. So very much thank you, and let's give them a round of applause. And we do have a little token of appreciation for you guys taking the time out for your day. Thank you very much. And I will just let you know that the next session is Purpose-Built Aerospace Systems. That's going to be in this theater at 10:45, so in about 15 minutes from now. So thank you very much.